Okay, we're live.
Thank you. All right, so good morning. So in case anyone missed that, you need to be in Windows on the dual boot machine. So please reboot in Windows if you're not already. So we had asked you to watch, actually, before we get into that, projects. So there are some proposed projects on the Canvas site. So you can have a look at those at your leisure. We're going to be discussing projects more on Thursday, right?
Yep, that's correct. There's going to be a set of project pitches on Thursday from stakeholders.
So, yeah, and we had offered to allow pairs to request that they stick together in group assignments. So please email the instructors if you haven't already and you're interested in that.
And CCing both sides of the pair.
Yeah. All right, so I'd like to start a discussion about the video that you were asked to watch. So it spoke about three major simulation modeling traditions. Can anyone tell me what one of those was?
Agent-based.
Agent-based modeling, good. What's your name?
Aiden.
And you?
I'm Pius, and System Dynamics is another one.
Thank you.
I'm Liam, and another one is distributed event model.
Good.
And the name was?
Liam.
Liam, thanks.
Thank you. So that covers the three. So I also wanted to discuss what aspects of a system does System Dynamics focus on? So there were two aspects of a system that System Dynamics is concerned with. Yes.
Based on like the countable thing that any point can model and flows on is like the rate of.
Okay, so that's not what I was looking for, but it's true that System Dynamics is the building blocks of System Dynamics or stocks flows.
Yeah.
So do you have any idea what I was back? Feedbacks and accumulations. So names, please.
Say that again? Hunt. Okay.
And
That's great. Thank you.
thank you. But yeah, that takes care of the next question. Stocks and flows are the building blocks of System Dynamics. What are some of the features of agents in an agent-based model? You in the red, please.
Populations are modeled on the basis of individuals who each have their own specific characteristics.
Yeah, that wasn't one of the ones I had, but that's correct. So what was your name?
Mark.
Thank you. Yes.
I think you have parameters.
Yep, parameters was one of them. Anyone else?
Like seeds.
Actions.
Yes.
Name.
Name, please.
Elliot.
Thank you. And you again, please.
Rules.
Yes, rules. Well, I think that covers those. And then moving on to discrete event simulation. What are some of the characteristics of discrete event simulation? At the back there, please.
And it focuses on the processes and the events at a specific time, like the specific point in time.
Yes. Name, please.
Soham. SOH.
Thank you. So anyone else, another characteristic of discrete event simulation? You haven't gone?
It focuses on the flow charts and capacitated resources.
Yes. So,
And
no-
Qs.
and cues, yes, that's another one.
Name?
Prishta, Prish.
Thank you.
So yeah, to summarize that, cues and resource constrained is another way to word it, workflows. And there was one other I had on my list, so does anyone know what I'm thinking of? So the things that move through the workflows are called entities. So entities demand resources that are limited in quantity, and they interact with other entities by forcing them to queue when a resource isn't available. So one more question, this one's from near the end. What is metalinguistic abstraction? What does that mean in plain words? What is metalinguistic abstraction? So I can, if there's a writing tool, I can write it out.
I've been searching for them with my eyes. Yeah,
There's
good.
Hopefully it works.
Are you? Yeah, okay.
Yeah.
Great.
So I'll write it over here to can't see all the way across the room. It's in their pen.
The cavalry's coming.
Does anyone have any idea what is meant by that term?
Wasn't that when the video was talking about purely representing the concepts with math, so it can be represented with anything, or was that a different part of the video?
You want me to? So metalinguistic abstraction is this idea that in modeling, like in other areas of computer science, we focus on building abstractions. And one of the most powerful ways of allowing us to work with abstractions is actually choosing our language. So different languages, different ways of describing a situation, let us capture different features of a situation with different levels of expressiveness or specificity, generality. And the idea of metalinguistic abstraction is in order to describe abstractions in a given area, say a workflow for a discrete event simulation, or say agent evolution in their state with state charts and agent-based modeling, or for a population as a whole, stocks and flows, we choose kind of a language that gives us the abstractions we want for our modeling project. We want to describe the world in a certain way and choose a language, way of describing the world that captures those abstractions at that level. And yes, they all have a mathematical roots beneath them that describe them. Whether how explicit they are differs by framework, but that's the essence of it.
Yeah. So maybe in a more concise way of saying it, it's choosing the correct language for the problem at hand. So each of these, and we'll see this in the coming weeks, each of these methods has strengths and types of problems that it's best attuned to solving. And when we get into hybrid modeling, you'll see that we can sometimes combine two or all three of them to solve a problem in a way that approaches different parts of the problem in the way that's most simple to represent them. So All right, is anyone still having trouble bringing up the AnyLogic program? I'm gonna try to get the
Looking to drop it.
HDMI. Yeah, got it. There we go.
Yeah, you're good.
Is it going to? Oh, there's my screen. Excellent. So I'd like you to download from the Canvas site. There's I should show that. So on Canvas, there's under models used in class, we have this SIR agent based for PLE, and I'd like you to download that and open it in AnyLogic. And I will do the same. So we're going to work on this exercise, and it's going to hand in at the end of class. So please try to follow along, and if you will try to give you a hand. So to start with, when you open the model, there'll be one tab here in the canvas, as it's called, and yours probably looks a bit different than this. I should do this. Thank you. So it's class, it's agent in Java, but it's kind of the program entry point for most AnyLogic models. So that's where stuff that applies to the entire model will reside. So in this main agent, we've got a space here. We've got some controls, which we're kind of going to ignore today. And we see we can have susceptible, infectious, and recovered. So this is a infectious disease model. And then if we scroll up, we have a graph of susceptible, infectious, and recovered over time. So if I select the main agent and look at its properties, I want to point out one thing in the agent actions. So this is Java code, and what it says is delivered a random agent inside infection. Question: are you stuck? Anyone else need a hand at this time? Okay. Yes. Yeah. Yeah. That, oh, there it goes. Well, you can guess that's this, I think. Oh, it's, so go to this here. The logic. Is already open. Okay, so I should show this on the screen because other people may be stuck there. So by default, any logic shows you example models, and I'll show you what it looks like on the big screen. So it shows this screen with a ton of example models and it hides everything else. So what you'll notice it on yours, this is likely checked, show on startup. And what I've done that's different is I unchecked that a while ago because I don't like to see this every time I open the program. And so if this comes up, you can optionally uncheck show on startup. And then you click on the X here. And that'll get rid of your example models. And it should show either a blank workspace or it should have the model we're working on in the background. So if you ever want to see the example models again, they're just in the help menu, example models. You were going to say something, EJ. Is my screen not visible online? Okay. All right. Anyone else stuck, or can we move forward with the next part of the example? All right. So yeah, this is main in this model. The other thing we have is on the left. We have these things are called parameters, and they encode assumptions about the model. And then these are variables which store information. And then we have a population of people. So this is a population of agents. And we're going to look at the person definition now. So if I go over to the sidebar here under projects and double click on person, it'll show us this. So this is how a person is defined in this model. So we have a susceptible. Maybe I should make this bigger. So this is the starting entry point for the state chart. And then people start as susceptible. And don't worry too much if this is a lot of information right now. We'll be spending more time on what state charts are, but basically a person can be in one of these states at any given time. So they start susceptible, they can become infectious, and they do that when they get a message from another person that says you're infected. And then while they're infectious, this little sort of funny little curved arrow here, if we look at the action for this, it says send infection to random neighbor. So while a person is infectious, they tell their random neighbors they're infecting them. If they're susceptible and they get one of those messages, they move from susceptible to infectious. And then at a certain rate, they will return to recovered.
And then what this is, and we're not going to deal with immunization in today's example, but there's a support for that in this model. So a person who's susceptible can get immunized, and that moves them directly to recovered, so they can't get sick. And people have a color, and there's a function here to count the infected neighbors. And we won't dive too deep into how that works today. But the important thing to notice about this state chart is there's only one way to go. Everyone starts susceptible. They can become infectious. They can move to recovered. There's no going back right now. Yes.
What happens?
Okay, so on contact, is this legible for you guys? Or is the text too small? Okay. I don't know what the best way to handle this. I guess I could change the screen resolution.
I think there's also a magnifier.
Yeah, there is. Let's try that. Oh, not now. Updates. Okay. I don't have that
Another
on
thing,
my
you could
control center.
copy it to a text editor.
Yeah, I think that's what I'll do. So I'm going to open a text editor. And how do we make this big? So this is in big letters what that code says. So it's sending a message called infection to a random neighbor. So if that random neighbor is susceptible, then they're going to catch the, well, we're talking about this in terms of a disease, but I think it's important to emphasize that it doesn't have to be an infectious disease. This type of model can be used to model the spread of like attitudes and beliefs, and as well as like viral new products, for example, as they become popular, things like that also follow the same patterns. Is that clear? Does that answer your question?
And what was the name there? Thank you.
Okay, so let's go back here to AnyLogic. And I want to call your attention to these X's in blue over here. These are what AnyLogic calls experiments. We like to use the term scenario. So I'm going to start the simulation, and you can follow along if you've got this open. I'm going to right click on simulation in the sidebar and choose run. There's a couple other ways you can do this. And so this is our running model, and it starts with a splash screen. It says run the model and switch to main view. I'm going to go over in the side and step the model. And then I'm going to go to the top level agent with this home button. And then I'm going to zoom out a bit so we can see more of, maybe not that much. Oops. So any ideas what you expect? And you could probably easily just run yours and tell me what it does, but it's valuable when we're making a model to think about what we expect it to do before we run it, and then see if the behavior meets or disagrees with those expectations, yes?
Oh,
Do you need help or?
no, I'm but it's. I'd be expecting it to kind of be exponential, so like, when you start with somebody getting infected. And then send the randomness, so they know they can do. Assays. That makes sense. I mean, like this, so,
Yes, what is your name, please?
Nicola.
Yes.
Like, I don't know, no part, it'll turn, like, not going to turn red, to the person that, spread out in that area. Because they're infecting. So, turned off their color over time, and then it'll spread up.
Yeah, that's a good hypothesis. Here's, yes,
So, yeah. But they're all recovered. If it's something change, if no one's infection.
so it's, unfortunately, our colors are kind of mixed up. But if we look here, it's, yellow is susceptible on this view. So everyone's susceptible right now.
Oh.
And that's probably a point where we could improve this model going forward, is to be consistent with the use of color. Name, please. What was your name, please?
What was it? Niebuhr. Okay, thank you.
Thank you. Any other thoughts on what it might do? Yes.
Since infections can only be spread through people who are already infected, how is it gonna start if there's nobody starting infected?
So
Name.
I pointed out in Maine, there was a on startup action, which you probably couldn't see because I didn't blow it up because the text is too small, but it says sent a random agent infection.
Oh, right.
So at the very start of the model, one person at random is going to get infected.
Name.
Hayden.
Thank you.
Find myself stuff.
Okay. Okay, so click on this. And it's not doing anything. Oh, there it is. It's just slow. All right. So we have some really good hypotheses about what's going to happen. Oh, did you want to say something?
I had one more in which the red or infection will spread, and then there will also be immunizations that start happening after the infection starts spreading.
Okay, what makes you think
Is
that?
that not part of, because it was part of the model that
We did.
susceptible people will get immunized? Or
We did have that option.
was that
but-
not part of this model?
For this scenario,
Oh,
we're not going to use immunization.
Okay.
So,
Yeah.
but that's a good comment.
Okay.
Yes?
Show how long it takes for someone to reassure.
Yes, we did. So if I just switch back to the AnyLogic editor, this transition from infectious to recovered, and I should put this in the text editor so you can read it. So it's at a rate, and we'll talk more about what a rate means in this context, but of 1 over the average illness duration. So average illness duration is one of those parameters that encode the assumptions about the model that sit in main. So that's the reason it says get main dot average illness duration. So if we go and look at main, there's an average illness duration with a default value of 15 days. So that's where that is placed, beside you, yes. Oh, name, please.
What is?
And yes,
Just the speed at which people get infected, does it change at any point, or is it just increasing at the same rate?
okay, that's a good question too. So if we go back to our person in the editor, This happens. So this transition is an internal transition. So as long as they're in the infectious state, they'll go through this occasionally. And the rate at which they do that is this. So it's contact rate over infection probability. And again, these are parameters in Maine. So if we go to Maine, there's a contact rate of 1 per day by default and an infection probability of 0.5, 50% per discordant contact. Now, another thing, I wasn't going to bring this up right now, but you'll notice if we look at our simulation scenario under parameters, the average illness duration for the particular scenario we're running has 10 days instead of 15. But all the other parameters are at their default values. And we know that because this one is bold. So that has a changed value from the default. Yes.
In the main model, when it comes to that graph that's up there, what exactly does the x-axis represent?
Okay, so the x-axis is time in days, and the y-axis, it looks kind of ridiculous because what any logic does is it puts in a bunch of random kind of, well, not truly random, but it puts in placeholder data when you're in the editor. So what I'm going to do here is move back to the running model, and you'll see it won't look anything like that. Yes.
How does it define neighbors? Is that just like exact direct cell beside it, or does it count in diagonals, or is there multiple cells around it that are defined?
So that's a good question. And I'll show you where we find that. In the main, there's a section of the properties called space and network, and it's an arranged space. So that means they're arranged on a grid, and the neighborhood type is Moore or 8 neighbors. So if this person it's going to be like this. If this person is infectious, they could potentially expose any person in the 8 directions around them.
And can I get the names of the last 2 people who spoke up?
Oh yeah, Eric.
Eric and, yeah. Sorry. I think there was someone else before that who asked the question.
I did ask, I'm Mark.
Mark again. Okay, awesome. Thank you.
Yes.
Yeah, Toby, I also want to ask the speed of the.
Okay, so you had asked the speed of the infection, right? Did you get Toby was the name?
Yeah, got it.
You got it?
Yeah.
Thank you. Okay, so I'm gonna go back to the model, and I'm gonna use these controls, and I'm gonna run for 50 days. And we'll see what happens in the first 50 days. So we see a random person in the space starts infected. And as some of you hypothesized, or one of you did, it's spreading out radially from the location of that first infection. And as someone else mentioned, gradually people are becoming gray, which on this view represents recovered. So there's sort of a front of infection in space, and it's growing outward. So I'm just going to make this go faster, and that's what it looks like. Now, if we go up here, and I'll zoom in a bit so the graph is more visible. So we have infectious here in red on this graph, which is consistent with the other views. So I'm going to ask, what do you think? Where do you think infections will go from here? Any ideas? In the next 50 days. Try to pick someone who hasn't gone yet, but I think you haven't gone.
It'll continue to rise, but like at some point it'll kind of plateau as the recovery goes up as well.
It's a good hypothesis. What was your name, please?
Alex?
All right, any other ideas?
So,
Yes.
So what you said, maybe the case, if there is no external, like any exogenous impact on the curve. In that case, it will follow the normal natural curve where it will go and plateau and then go down after no person is susceptible any longer.
Good. So what do you think? Do you think we have exogenous influences on this model based on what we've discussed about its structure so far?
As of now, no.
Good.
I don't think so, but that's what I was saying, that looking at the model as it is now, there's no exogenous impact, so it will follow what you suggested.
Yes.
If there is, because in natural phenomenon, we are assuming that nothing impacts on it from external, but in real sense, things impact on it. So if things impact on it, then it may not follow that curve.
Yeah, that's an important point. Thank you for that. So let's run for another 50 days and see where this red line goes. And how does that compare to what we thought? So it looks like our hypothesis holds out. So what do we think for the why do you think that happened? Does anyone have any idea about any thoughts about why it starts to plateau? Yes.
By the time the infectious start to down, because we don't have any transition background recover to other susceptible or infectious, and after a time the number of infectious reduce and all people go to their recovered state.
Okay, name please. Name. Great. Did someone else have a comment? Yes.
I think it's plateauing because it's hitting the edge of the boundary.
Okay, that's a good hypothesis. Name.
Eric.
Thank you. So let's back out here and see if that is true. And lo and behold, it has hit the boundary at the top and the left side. So that was a good hypothesis. Did you have something to say? Okay. No.
Yeah, I have a question.
Yes.
So this hypothesis that it plateaus because it hits the boundary. So that's a technical way of putting it. So how would we say this, let's say, to a lay person that who is, let's say, participating in, say, a group modeling? How do you explain this? That okay, it plateaued because it hits the edge. How do you explain it to them?
Well, I think probably a more plain way to say that would be that like, say this yellow went forever off the screen. This would probably be a big round circle like that. But it's actually kind of, we're running out of susceptibles. Because we got to the edge of the boundary of the model, and all of this now is recovered, and it's only growing on this arc. So I think probably the plainest way to say it is we're running out of susceptibles, which I think someone else said. And this is kind of an artifact of one of the assumptions of the model, which is that people exist on a square grid. Yes.
I was just wondering, is there a period of time after which the recovered people will become susceptible again?
Not yet, but we're gonna do that in a few moments.
Last question here.
Yes.
Are there random seeds? Because you could run that same situation again and have a different result because of the randomness.
Yes, we're gonna talk about that as well. Name?
Pious.
Thank you.
Thank you. Oh, where's my notes? Sorry about this. I'll just take a moment to cycle my Wi-Fi. Okay, so those were some good ideas, and they're ones I intend to explore in this exercise. If my notes would show up on my tablet. All right. Well, we might have to freeform this a little bit. So say we run this for another period. Oh, look at this. The infectious are going down now. And our recovereds, there's a huge amount of recovered people. And susceptible, which is purple on this graph, but yellow down here, sorry, is going way down. So I'll run for another 50 days to 200. And by 200, the infection has totally died out. And okay, maybe not totally. We see a few reds in a sea of recovereds. And what's this?
Like, he was not infected in the first place.
Yes, exactly.
Name?
SK Sidratu.
Just say that again?
SK Sidratu.
Okay, yes, right, got it. Thank you.
Okay, the infection nearly died out by 200 days. If we run for another 50, I think that'll be it for that. And we've got two lone susceptibles that luckily never got the infection. So I'm just going to close this running model. Now we have some other scenarios here. So one says a fast recovery. So I'm going to right click on fast recovery and choose run. And for the sake of discussion, I'm just going to step it. So we're at time 0, but it's brought up the running model. We can worry about that later in terms of so how do you think this will be different? Fast recovery? Yes,
I think it'll be similar where it's a random infection starts spreading like the whole world pattern, but then there's no recover faster. The rate of infection will go down because it'll block off potential users to get infected. Like some of them will recover before they can infect others.
that's a good idea. Yes,
There'd be more susceptible stuff open. Have buildings, everything.
that's a good idea too.
Name?
And,
Randolph. Thank you.
And with someone over here,
basically, a lot of people will get infected and they'll recover so fast that people, I guess they're not so infected. They just won't get infected.
right, so that was a similar idea. Did you have something?
Na-
I
Name?
don't know how fast it recovers, but it's possible the disease might die out before it like infects a large amount of the population.
Okay, so your name, please,
What is it?
Needed.
Oh, new.
and you.
Thank you.
Thank you.
What's the last one? The fun.
Robert?
Robin.
Thank you.
Sorry.
Thank you, Robin.
All right. So let's have a look at what this does. I'm going to do it in steps of 50 days again. Oh, look. So we had a random person became infected. And it spread a little bit. And then it died out. So let's look at the graph. I'll zoom in on it a bit. So there's like a huge fraction of, I don't understand these numbers, but
Those are the number that are infected at the time or the interpolation thereof.
right. Okay, there we go. Susceptible is like 49,000 out of like 50,000. So very few people got infected, but so let's try running this again. So this one, and I kind of got derailed because my notes disappeared, but it's different this time, right? So here we see, this is after 50 days again. It started down here somewhere. We still see bits of infection spreading. And then another 50 days, and this confirms another hypothesis that someone suggested, which is there'll be more susceptibles left over. And we can run again. Oh, look at these. So what do you think is going on here? I think it aligns with what some of you said before we ran it. That people are recovering too fast to infect all the people around them. Right? Does anyone have any other thoughts on that? Yes.
Like in the last one was kind of like a circle with the time, but this one you can see where it's like the circle, all of them recover, and then there's like the one part that didn't recover, and now it's turning to it.
Yes. So, and I want to ask you another thing. So we had a question about something called a random seed, which some computer scientists would know what that means, but Maybe some of those from other disciplines may not. What do you think? Does this have a random seed?
Every seed has a random seed. Well, every random has a seed.
Yes.
Maybe, I don't know.
Okay, let's have a look. So,
That name?
yeah, Pius. Yes,
Thank
you answered previously. Thank you.
Yeah.
So there's actually a section. So I'm going to start looking at the simulation scenario, which we ran first of all. And in the properties here, there's a section called randomness. And we can have a random seed or a fixed seed, and we can specify the value of that seed, or we can create this is more advanced, but we can create a subclass of the random class in Java and have our own random number generator. So simulation uses a fixed seed of 1, but fast recovery has a random seed. So let's just go back to simulation. I'm going to run this. And let's run it for 100 days. Fast. Okay, so this is what it looks like. Now, let's run it again. Oh, I ran it full speed. Oh, silly me. All right, let's try this one more time. We'll run it for 100 days. And, oh, look at that. It's the same because it has a fixed seed. And this is an artifact of how computers generate random numbers. Yes.
The chart, you see that we have the susceptible, and then the infectious, and then the recovery. The positioning or where each of these are from, does it have, is there a reason for it? Why is it that the susceptible is not, let's say, at the upper part of the chart, but at that extreme end, and the infection, does it have a reason, or it's more random?
Okay, so we talked, sorry.
When you're asking the upper part of the chart, you talking this graph that's shown now or what's below?
Yes, the graph.
Okay.
No, not this one. I mean
The what's below.
yeah, what's below.
Yeah.
Oh, and the spatial.
Yes, so does it have any spatial reason why the susceptible is at the lower part and not at the upper part of it? And
Well, because it happened to start up here. But because of the way we're treating random numbers, which is what I was trying to get us to discuss, it's the same every time because we have the same random seed every time. And this, sometimes you want that and sometimes you don't. But I'll show, if I can continue this demonstration for a moment, I'm going to change this seed to 2. So this simulation, it's still a fixed seed, but I changed the number. Let's run. And I'll just get this on screen. Let's go for 100 days. Oh, look, it started in the bottom right now, this time. So, yes.
So are the seed values pre-saved runs of it, or is it designating, oh, the first seed is starting here, and the second seed is starting here, and the third.
It's
seed-
not actually saying a person here gets infected. It's saying a random person of the whole population gets infected. So
And it's saved as seed number 1, seed number 2, seed number 3.
it's not really saved. What's happening is we set the seed of the random number generator. And then it actually has a predictable sequence of numbers drawn from the random number generator after the same seed is entered as the initial seed. Right? Are you a computer scientist or are you a health practitioner?
Computer science.
Yeah, so pseudo-random numbers, which is what we're dealing with, are actually really long sequences of repeatable numbers. And we usually have a random seed at the start of our random number generator. So for all intents and purposes, to a person, it appears random. But you can force the same sequence by starting the random number generator with the same seed every time.
Okay.
So what's happening here is we haven't changed the model structure. So it's calling the random number generator in the same sequence of operations
Of random number.
of random numbers. So unless we change the seed, we get the same behavior every time because it's doing the same thing.
Okay.
So we can change the seed, or we can change the model structure. We change the model structure, we will change the sequence of calls to the random number generator, and that will change the behavior also. Is that clear?
Yep.
Yes.
So a name?
Aiden.
Aiden, thank you.
If you run with a random seed, is there a way to see what seed you're running with? While like in the simulation?
Yes, but it's a bit more technical, so if you want to do that, we can. It can be done. This is a framework around Java, which is general purpose programming language, so you can do that, but if you get off the beaten path of some of the things in the graphical user interface, you have to do more programming. So let's just stop this and just so we can confirm that it's different from the previous time, but it's the same every time. We're going to run this for 100 days again, and oh, it starts in the. That is very strange.
You might have found a bug. Is yellow recovered?
Yellow is susceptible there.
Did you run the wrong scenario? Or
I don't think so. Because I didn't close it. Oh, there we go. Might have been a graphical bug. This is what it should look like, which is the same as 2 times ago when I ran it. Now, if we say a random seed, then it'll be different every time. So we've got about half an hour here. I'm going to run the slow recovery. And let's think about how this might affect the simulation. And I want to get to introducing waning of immunity. So does anyone have any ideas about what we might expect with a slower recovery?
The infectious rate would rise, like quickly, and maybe there would be a time where everyone would be infected.
Okay, that's a good thought. Yes? Name,
Go on.
so,
Would be more effective than susceptible and recovered at like a certain period of time.
all right. Yes,
By the end, there should realistically be no susceptible and eventually all become recovered after X amount of days.
okay, those are some good thoughts. Let's, yes,
I think the number of infections at the time has a maximum, and if we have a slow recovery, the maximum is higher than the, for example, faster. Has a greater maximum.
okay, that's a good thought, and one more at the back.
I don't know, but I think like everyone like will get infected towards the end, but no, everyone will get recovered. I mean, but I feel like they will continuously get infected. Like you'll get infected and recover, infected and recover.
Okay. Name?
Toby.
Toby, thank you. So let's have a look. One more thought? Yes.
Because they don't have anything where they can be infected, they'll spread faster, but then, they'll overcome time. There'll be less days with it.
Okay, that's an interesting thought. Let's have a look now. So I'm going to run this for 50 days. So does this, any thoughts on this after 50 days? We can look at the graph too. It seems that infectious is climbing faster than it did before. Let's run another 50 days. So remember, in this first scenario we ran, the second 50 days, it was already starting to plateau. But look at this. It's still climbing. And let's quickly look at the map. So we see a lot of red, there's some gray, and there's still quite a bit of yellow. If we run for another 50 days, and then, so that takes us to 200 days. Let's have a look at this graph. So someone said that the total number of infectious would be higher at the peak. And we see that. It's actually, we're at 200 days. So if we run for another 50, and you may not remember this off the top of your head, but in the first scenario, it was all done and dusted by 250 days. But here we still have infectious at 250 days. Yes.
When, yeah. And so it went to the end, so it's kind of like the recover block this way. And I see it got the same pattern as this one. It's still going outward as a circle.
Yes.
But as it go like outward and the recover is really slow. So it's like the rate is like and it got like it had more time days to
I'm not sure I really follow. So you said it has more days to die out?
and like more like the slower of the rate of recover. So that's why the rates of the infectious like going down when we going to the end.
Did you
I
name?
kind of
Name?
agree with her, and I understand that the natural history of the infection lasts longer. So instead of the infection clearing up quickly, it's lasting longer. So the more it lasts longer, the more you see the incidence or the prevalence increasing. And it's not like they're having more infection or the infection is spreading faster, but because it's lasting longer, if one person gets it, instead of clearing up within, let's say, 10 days, it's now taking about 21 days for it to clear. And so within that 21 days, you still see that there's infection. It doesn't mean someone else had been infected, but rather it's the natural history of the infection, which is longer than the usual one. If I understand what I'm trying to say.
Does that align with what you were trying to say? Yeah,
Great.
so those are good
Name?
points.
Name?
What was your name, please?
What was it?
Lynn?
Lynn, thank you. Thank you, Lynn.
All right, so I want to get to adding a waning of immunity. So I'd like you to go close the running model if you have it running and come to the person. And we're going to do a bit of editing here. So this palette actually by default is up here.
You might want to make waning.
Yes, thank you. So what I mean by that, so we said, or I said earlier, there's only one way to go in this. Everyone starts susceptible, and then you can get infectious or eventually become recovered, but you can't go back. So when I say waning of immunity, what I mean is, what if after a certain amount of time, you could go back from recovered and be susceptible again and catch the infection second, third, fourth time? So we're going to do a bit of a change to the model structure. So in your AnyLogic, there's two tabs up here in the upper left. There's the projects, which we've been looking at, and then there's a palette. And I had rearranged mine a bit, so, but this should be what it looks like on yours. And we want to go to a section of the palette called state charts. And then we're going to drag in a transition. And stop me if I'm going too fast. I can repeat the instructions.
Where does it say state charts?
Yeah,
Okay, I'll back up. So palette, state charts on the side, and then a transition, which is the arrow, and drag it from the palette into the workspace.
Did they find the state chart?
Is anyone still stuck? All right. So this is an arrow. It's got a clock on it right now. We'll talk about that in a minute. And it's got two little handles on the end. So I'm going to take the tail of the arrow and connect it to recovered so that it churns green. So when I say it turns green, this little round nubbin here turns green. This is still red because it still needs to be connected at the other end to something else, and it's not happy yet. This little tiny thing here is green because the tail is connected to recovery. And then we're going to put this to susceptible, like so. And then I'll show you a thing. You can double click on these arrows to put angles in them. And if you put an angle in that you don't want to see, you can double click it again and it goes away. So you can do that to keep it a bit neater. So now we have the structure for people to get susceptible again, but we want to encode the time it takes for that to happen as a parameter in main. And the reason for that is we want to change it from different scenarios. So if I go back to the palette, I'm in main now. So make sure you clicked on the main tab at the top middle here. Come back to the palette and go to the agent section. So make sure you're on main, come to the palette, agents, and then we're going to drag a parameter in. And we're going to name it mean duration of immunity. And hit enter. So the properties of this, we haven't filled it in yet. It's a double precision value, which we'll talk more about later. I'm going to put 90.0 in there as a default value. Yes?
Stop at the place where you describe the parameter. I can't see it in the
Okay. So
Name? Oh, thank you. Thank you for.
then what do you need a hand?
Yeah, my thing is like, what's the parameter called? Mean duration.
Mean duration of immunity, and I can put that in big text here for you. Thanks for asking. Anyone else need a hand with following along? Yes?
Are we waiting for the?
Sorry? Yeah, so you're in Maine, but no one wants to come here. And we want to go here where the other. I see how far we're supposed to go to see. And then we're gonna name it mean duration. Yes. 9.1 meter from home. Anyone else need a hand? We have 15 minutes here. So. All right, so we've got a parameter in main now called mean duration of immunity. Its default value is 90.0. I'm going to go back to the person and I'm going to type a little bit of code. So I'm going to go to that new transition we put in from recovered to susceptible. I'm going to go to its properties. I'm going to give it a good name. Called it waning of immunity. It's good to name things descriptively. It's easy to get in the trap of not naming your transitions, but it's a good practice to do so. Now it says it's triggered by a timeout. I'm going to change that to a rate. And then in the box for the rate, I'm going to type main dot mean. And then I'm going to invoke something called autocomplete in the software. So control space on a PC, option space on a Mac, if we have any Mac users. We'll bring up this little window that gives you options of acceptable code that completes what you started typing. So I'm going to choose mean duration of immunity. And that's not right because it's a rate. So this should actually be 1.0 over, and I'll put this in the big text so you can see it. So this is the code that goes into the rate box of that transition. So raise your hand if you're stuck. I need a hand. Yes. Yes. So you're on a Mac, so press Option Space.
Anyone need help here?
And pick the first one. There we go. So if it's hard to read, you can drag this. Okay, so I sort of corrected myself. It's actually 1.0 over that.
Oh, same line.
As on the big screen. Option space. Anyone else see the hands? Any other people need help? Yes. Yeah. So, okay.
Wait, you want me to take over so you can?
Yeah, if you could.
Sure, or I can.
Or you can help here.
Yeah.
Yeah, thank you.
Oh, okay, thank you, Joe.
Okay, so we're kind of running out of time. So this rate transition should actually be 1.0 over mean duration of immunity. And there were a couple things I was going to do, but I got sidetracked. So let's just run the simulation scenario with that change to the model structure that we just implemented. So quickly, we got 10 minutes. Any ideas about what do you think is going to happen now that we made this change in the model structure? Yes.
Yeah.
Oh,
Yeah.
so we got like 3 minutes. All right, let's run this. Oh, we got 0 minutes. Well, I'm going to run it so you can see and you guys can start packing up.
We'll run the model and you can run.
Yes. Sorry about that.
You have to submit this file as a handed.
Yeah.
Before 1 p.m.
Yeah, what do you think? Should we can that or
Uh,
do you want them to submit it?
we'll extend the deadline till.
We'll extend the submission till the beginning of next class. We'll do that on afterwards. So let's quickly. Let's have a look at what this does. 100 days. Not too different, but we see some yellows coming back. Another 100 days. It's still burning, but it's kind of all over the place, right? So there we go. Thank you for your attention. It's time to pack up. So we'll revise that instructions on Canvas
I've already revised it, so be sure to turn in your model that you built in class to follow along with the exercise by no later than the start of class on Thursday.
Thank you.
But you can do so immediately if you happen to have time. Thanks.
All right, thanks, everyone.
Just hand in as is, like. if we-
And then as is, I had planned more for it, but
Okay.
we ran out of time, so yes, please hand in as is.
Yes.
So we've got office hours now, so if you don't have to run for another course,
We're glad
we
to
can,
know.
we're glad to speak with.
Also, I wanted to just ask on a few people's present, is ECOC here? Or Shivam? Or Chris Guda? Great, thank you. Or Kurt Hoffman? Awesome,
There.
thank you. Or Abdul Kadir? Okay, or Sarah Kostak? Awesome,
There.
thank you. Nishant? No, Cameron Parento? No, EJ, maybe you could help over there. Jimin Park? Jimin Park over there? Okay, thank you, Jimin. Elliot Vaughan? Thank you. And Roshin? Awesome, thank you. Thank you for your patience asking to have your names. We're just trying to learn people's names so we can better understand your needs and dialogue with you. Yes.
1.0. Okay.
Yeah. You would have missed the first prerequisites. But the most important thing would be for you to look at the syllabus. Okay, good. And the key thing is there's going to be, you probably, if you register on Friday, you may have received announcement about like the video to watch for today. Awesome. In the syllabus, it shows a bunch of videos that will be asked over time, so you can get a leg up in watching those if you like. Yep. Sorry.
So we didn't start.
So we're about to start making groups, but we're going to have stakeholders, sponsors of projects here on Thursday, and the groups will be formed based on people's preferences. So we had noted that they're random, except if two people indicate they want to work together consistently, we'll try to prioritize that. And we're waiting for more people. We've only received one pair at this point, and we're looking for more. But we'll be forming them before the end of the week. And we're also trying to make sure who's really in the class, who's not, hence me asking, like, are people, etc. Because some people may be joining, some leaving, and we want to be sure we can randomize the right set and have people on team, okay? And your name?
98.
Liam?
Yeah.
We had left
Yeah.
blank.
Is there any chance we can propose?
So we just.
If you'd like to bring ideas for a project, we're glad to consider it.
Okay, and would I have to get a stakeholder before that, or is that?
No, if you have a stakeholder in mind that you think might be interested, and you could mention that would make us especially favor
Okay.
and think that that's a good, strong project idea. But it doesn't have to be that they have to commit to it yet, so you'd have time to discuss it with them. We wanna dialogue with you to make sure that we can set the expectations on your part and the part of the stakeholders, so it's not unrealistic, but also to make sure it's a good match for what this class can cover. And so we want to chat, but we welcome that initiative. I think that's a very strong contribution participation wise into the class, and I appreciate it. Your name?
Akshina.
Akshina.
And would that discussion be like on a separate time or like during this?
Well, we could do so in office hours. We have office hours after class today, well, Tuesdays, Thursdays, an hour after class. We try to do it in this room if possible. We'd like to talk, otherwise, Wade and or I could talk and if we could make a time of range. So if you're like to see this, I mean, you could.
Wait until I'm.
Okay, say sure. Yes, your name. Okay, your name is. I appreciate it. You were one of the people who spoke up during class since I reported. So I didn't bother reading up people's names who I knew were here from what they were saying. Thanks for coming on. Yeah. Good, you were just nice. Yeah. Yeah, your name.
And if you want to come, you'll have to know.
Well. Yeah.
If you want to come, it's.
Yes.
Yes, this Thursday.
So last.
Then it'll probably go. But
Yep.
are you master's?
Oh, I see.
Masters, okay, so then projects that and very important will be nice.
Yeah.
It's-
Yeah.
Be sure to do it no later than the beginning of class.
Get people from undergrad, or project numbers, like, or.
Yes, that's right.
So I don't think that we can.
And so, yeah,
Have the
you have
offer,
the good more, take that, but that'll be one of many minutes.
but yeah, definitely push back.
So,
Okay.
okay, so.
And are you I should have asked, are you a grad student or? Okay, great, great. That's still something we welcome, it's especially.
So if, like, for example, the project idea was or not, looking into was you can kind of, yeah, not production, simulating. Rather Alzheimer's.
Very.
Because I've done.
That's on.
From a college class.
Yeah.
But if I can't get my group to want to
So
do that,
was it Queens?
is that it's just like that? Follow it,
Well,
or is
what
that
we
can't?
probably try to do
Yeah.
is let people know that we have
Someone
someone who's coming with background knowledge and who could,
You're not.
we could help perform this. And we could welcome people who are interested in that.
It'll be
To
discussed.
see if there's a group that can be formed around that. It's my thought. I'll talk with Wade about it.
Cause I
Yeah.
am so
Yeah,
passionate about it.
Yeah.
To the point where I would,
yeah.
if it's not possible, I would put in the work to do it myself, but if that's not.
See if just like that. Yeah, so, I've worked quite a bit with dimension modeling and,
Okay.
but not at the brain level, the neuroscience level. So I have a lot of learning to do, but I have some strong collaborations in that area with geriatricians. So I'm familiar with aspects of the situation at a broad level. I'd love to learn more, figure out, how it could be crafted into an appropriately scoped.
Yes, yeah, I was reading about even just the
Yeah.
scopes and stuff, and
Yeah.
it really depends on what we're expecting.
Yeah, but I'm confident knowing something about, I mean, I read quite a bit on Alzheimer's, including some more neuroscience.
There's been more about.
And-
Watch the.
And I'm convinced that it could be rendered into purpose. So I think it's a matter of with any formal stakeholders that you bring to the table, also just making clear what we could explore in the process. But really interesting. I'll chat with Wade and then maybe we could learn more. I want to make sure that I can. Yeah, well, yes, what we look for really is participation. I understand, no, I get that, but from now on, try to, yeah, asking a question, making a suggestion, coming up to chatting for office hours, although.
How much it is? Like,
They are not
Now you're after.
Infected circular.
I see. Well, also,
Honestly,
and again, you're Mohammed.
if you,
Yes, thank you. So,
if you answer one question,
Go ahead. Okay, thank you. Yes, you're Mark, okay, yeah.
It's just sort of
Yeah.
right now, I'm signed up for a number of classes, and I'm probably gonna have to drop some of them. Whole classes that was 400 classes.
Yeah.
Yeah, I guess,
yeah. I
sort of
mean,
like,
it's sad.
I guess my question would be,
A
like,
lot of
is the
students-
class, like, it would be, like, interesting to take, and, like,
Try to-
teach style stuff, I don't know if it's.
I don't know if you've been in a class where nobody.
You
has-
said, when you run the code, you can have that.
Got enough time.
But I thought about.
Come on, next.
So you have a pretty heavy load, eh?
Yeah,
Yeah.
I'm gonna have to drop something, but
For
I'm
this-
still,
For
like,
this code.
effectively, if I were to take, basically 300 level classes and a 400 level class every term, then I could get.
I'm glad you like
for a regular degree,
Yeah.
but it's just one of those things where it's like.
Mhm.
Some, like, there's the operating systems class 332.
Yes.
Which, I imagine will probably be quite heavy,
It's a very heavy load.
yes, and then 442 is about, compilers.
Yes.
stuff.